Welcome to section 8.5. This is the 69th session of the CISSP exam prep series. In this session, we'll survey the built-in security features of information systems. We'll answer several questions. What does memory protection do? How does virtualization help security? What is a trusted platform module? What is a secure enclave? What is a constrained interface? What is fault tolerance? What role does encryption play? And how do you manage a system across its whole life cycle? Why does this matter beyond the exam? Because you cannot evaluate a platform you do not understand. Imagine you are choosing hardware to protect encryption keys for a payment service. If you cannot tell a chip that guards keys from one that merely stores files, you cannot judge the design. Knowing these capabilities lets you match the right protection to the right risk and lets you spot when a vendor is missing something essential. So what does memory protection do? It stops a running process from touching memory that was never assigned to it. This has to be built into the operating system and enforced no matter what program is running. Without it, you invite instability, broken integrity, denial of service, and data disclosure. It is the low-level fence that keeps one program from reading or trampling another's working space. Think of assigned lockers in a gym. Your key opens only your locker, and you cannot rummage through anyone else's. How does virtualization help security? Virtualization lets you run one or more operating systems inside the memory of a single physical host. Beyond squeezing more from your hardware, it is a genuine security tool. You can isolate operating systems from each other, and you can detonate suspicious software inside a throwaway virtual machine without risking the real host. If the guest gets infected, you simply delete it. Think of a bomb disposal containment chamber. You examine the dangerous item safely inside a sealed box, and if it goes off, the blast stays contained. What is a trusted platform module? A trusted platform module is a dedicated cryptographic chip on the system board used to generate, store, and process encryption keys in hardware. It commonly anchors full disk encryption, keeping the keys off the general storage where malware could grab them. It is one example of a broader category called a hardware security module, a dedicated crypto processor that manages keys, speeds up cryptographic operations, and includes tamper protection so it resists misuse, even if someone gets physical access. Think of a hotel safe bolted into the wall of your room. It guards your valuables right where you need them, and it is built to resist being pried open. What is a secure enclave? A secure enclave is a hardware-protected region that isolates code and data so completely that even the operating system, the hypervisor, and other privileged processes cannot peek inside. That extreme isolation makes it ideal for guarding the crown jewels, like cryptographic keys and, increasingly, valuable artificial intelligence assets such as proprietary model weights and training data. By running sensitive workloads inside the enclave, you keep them confidential and tamper-proof, even if the surrounding system is compromised. Think of a sealed clean room within a factory, where the most sensitive work happens behind a barrier that even the plant managers cannot cross. What is a constrained interface? A constrained interface limits what a user can see or do based on their privileges. A full privileged user gets every capability, while a restricted user gets only a slice. Applications enforce this in two common ways. They may hide an option entirely when you lack permission, so it never appears on your menu. Or they may show it but grey it out, visible yet unusable. Either way, the goal is to restrict the actions of authorized and unauthorized users alike, and it is a practical, everyday implementation of the Clark-Wilson model. Think of a self-checkout screen where the void item button is simply missing until a supervisor taps their card. What is fault tolerance? Fault tolerance is a system's ability to suffer a failure and keep running. You achieve it by adding redundant components, like extra drives in a redundant array of independent disks or extra servers in a failover cluster. It is a core part of avoiding single points of failure and building in redundancy, which is why it sits at the heart of resilient security design. Think of a commercial aircraft with multiple engines. Lose one, and the plane still flies safely to its destination. What role does encryption play? Encryption is the workhorse that turns readable plaintext into scrambled ciphertext, and decryption reverses it. Using both symmetric and asymmetric methods, it protects confidentiality by hiding data from prying eyes, and it supports integrity by proving data has not been altered. It underpins a huge share of the security solutions you will ever deploy. Think of a locked diplomatic pouch. Only the party with the right key can read what is inside, and any tampering shows. How do you manage a system across its whole life cycle? Security is not a one-time event. It runs from cradle to grave through 9 stages. You begin by gathering stakeholder needs, then analyze those requirements in detail. Next comes architectural design, the blueprint, followed by development where the system is actually built. Then you integrate the pieces so they work as a whole, and run verification and validation to confirm it meets its goals. After that is transition and deployment into live use. Then the long stretch of operations and maintenance, where you monitor, patch, and sustain it. Finally comes retirement and disposal, where you decommission cleanly, dispose of data safely, and stay compliant. Think of owning a car, from choosing it and driving it, through servicing it, to responsibly scrapping it at the end. Security belongs in every stage. So let's bring it together. Memory protection fences off each process. Virtualization isolates and contains risk. And hardware like a trusted platform module and a secure enclave guards, keys, and sensitive workloads at the deepest level. Constrained interfaces limit what each user can do. Fault tolerance keeps systems running through failures. And encryption protects confidentiality and integrity everywhere. And you weave security through all 9 lifecycle stages, from gathering needs to secure disposal. Understand these capabilities, and you can evaluate any system with a clear eye. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.